Hello, everyone, and welcome to today's Knowledge is Great lecture, Rising Tides, Sustainability Across Our Blue Planet. My name is Lissy Varakale. I'm the Head of Education at British Council Singapore. The Knowledge is Great lecture series was launched by us in Singapore in 2015. It showcases the UK's knowledge, creativity, and innovation by inviting leading UK specialists to speak on areas of topical debate and discussion. We'll be running these lectures once a month for the rest of the year, typically on the last Thursday of each month, whenever possible. So do look out for our invitations to future lectures. Now, before we begin today's session, could I please go over some housekeeping information? We have close to 300 participants joining the session today. So please put your microphones on mute unless you wish to speak. I'll just pause here for a moment so that you can check that your microphones are on mute. And while you're at it, please turn your video cameras off as well so that we can conserve bandwidth throughout the session. Let me give you a quick run through the program. First, I will invite Ms. Alison Barrett. She is our Director for Education and Society for British Council East Asia, to introduce our speaker for the evening, Dr. Ivan Haigh. Dr. Haigh will then deliver his lecture. If you have any questions that you would like to pose to Dr. Haigh, you could type these into the chat box as he is speaking, or else you could unmute your microphone and ask your question at the end of the lecture, and Dr. Haigh will try to address as many of these as he can. We will aim to close the session right on time, as Dr. Haigh does have another appointment immediately following this one. Please take note that we are recording the session for the benefit of those who could not attend. And an important point, please also take note on the accessibility of the session. So Ms. Amira Osman from the Singapore Association for the Deaf will be providing Singapore Sign Language interpretation during the lecture. Please pin Amira's video to your screen if you would like to access the interpretation. You can do this by right-clicking on the 3 dots icon right next to Amira's video and then selecting the pin option. This will ensure that her video remains visible to you throughout the lecture. I'll just give you a little time for you to check that out. So you'll find next to Amira's video, you'll find 3 dots. Just right click on that, select pin, and that'll make sure that her video is always visible to you. And the second part, you can also choose to turn on closed captions. For this, just right click on the 3 dots icon at the top of your screen. That's the toolbar right next to the chat icon on your Teams screen. And then when you scroll down, you will see a CC button, and you could turn that on for closed captions. Now, the captions may not be 100% accurate, but they would still be useful to you. So without further ado, let's begin. I'm very pleased to introduce Ms. Alison Barrett to you. Alison is our Director of Education and Society for British Council East Asia. She is also British Council's Global Lead for COP26, the 26th United Nations Climate Change Conference of the Parties, which the UK is organizing in Glasgow in November this year. Alison will provide this evening's opening address and will then introduce our speaker to you. Over to you then, Alison.
Great, thank you very much, Lissy. I hope you can all hear me. So good afternoon, everyone, or good morning to those of you joining us from the UK. It's a real pleasure to be with you all here today, and thank you so much for joining us for this afternoon's lecture. So as Lissy said, we started these lectures in 2015 as part of the Knowledge is Great series. They're a platform for academics, for practitioners, for students, and for the general public to really engage, build new knowledge and understanding on diverse topics across the arts, across science, education, the environment, and more, all very core areas of work for the British Council's collaborations between the UK and Singapore. This year, the Great Lecture Series will explore key growth sectors and future jobs, showcasing topics of significant interest both to the UK and to Singapore, and also to countries globally. Environmental sustainability is the theme today. It's one of our core themes, and I'm really happy to be here today because in my role supporting the British Council's engagement with the environment and with climate action, it's a very important part of my role at the moment. So the UN Sustainable Development Goals were adopted by all United Nations member states in 2015. They're a universal call to action to end poverty, to protect the planet, and to improve lives and the prospects of all of us everywhere, wherever we live, wherever we come from. Countries across the world are adopting measures to rebuild their economies in ways that are green, clean, safe, and more resilient. But much, much more needs to be done. World leaders have called for 2020 to 2030 to be the decade of action, with redoubled efforts to mobilise financing and to support the implementation of measures that will help us achieve the Sustainable Development Goals by 2030. We're looking at global action, local action, and people action. The UK, as Lissy said, will host the UN Conference of the Parties in November in Glasgow. There will also be a Youth for Climate event in Italy leading up to that in September, which the British Council is also engaging with. This is bringing together over 30,000 delegates from around the world, including heads of states, climate experts, campaigners, in order to agree a coordinated action plan to tackle climate change over the next period of 5 to 10 years. Looking ahead and extending beyond COP26, the British Council is really trying to bring together all of the stakeholders that we work with across arts, across education, science, English, to identify new ways and innovative ways of working together to create new solutions, new understanding, new learning, new knowledge together across nations and across generations. We hope in this way that we can really add value to those deliberations through a more cultural lens rather than a purely political lens. We'll be working with individuals, with organisations in the UK and around the world. We'll be bringing them together through research programmes, through a programme of creative commissions to engage young people. We'll be working with city leaders. We'll be thinking about the impacts of climate migration, looking at the role of women and of girls' education. And we'll be really trying to see how we can build new connections through all of those different programmes. So in today's lecture, we're focusing on an aspect of climate around the oceans. So the title of the lecture is Rising Tides, Sustainability Across Our Blue Planet. Dr. Ivan Haigh will speak about some of the stresses our oceans are facing, about pollution, overfishing, the destruction of marine habitats, oil drilling, and indeed climate change, and what we can do to reduce these pressures on our blue planet. Let me briefly introduce Dr. Haigh to you. He's an associate professor in coastal oceanography at the University of Southampton in the UK. He's regarded as one of the world's leading experts on sea level rise and coastal management. He gained his undergraduate degree in oceanography and his PhD from the University of Southampton, but he continued his postdoctoral research at the University of Western Australia. He and his team investigate variations in sea level and the impact that this has on coastal cities, on deltas, and on small islands. So I'm really looking forward to hearing your lecture this afternoon. Thank you very much for joining us. And now over to you, Dr. Haigh. Thank you very much.
What planet is this? Could you just take a second and put it in the chat? What planet are we looking at now? I'll just give you a second to put that in the chat. Well, it's an easy one. We're looking at our planet. We're looking at the planet Earth. Now, I always chuckle, I always laugh to myself because we call this the Earth. But if I spin this exactly 180 degrees, this is what we see. I don't think we should call this the planet Earth. I think we should call this the planet Ocean, because our planet is more than 70% ocean surface. Not only that, but the ocean contains about 99% of actually the living space on the Earth. That the land only makes up 1% if you take that kind of three-dimensional structure. The ocean is very deep, up to 11 trench. Average is about 3.84 kilometers deep. So it's a huge space, a huge volume of water there. Now, what I want to do in this talk is I want to tell you 7 reasons why I believe the oceans are so wonderful, So let's start really positive. Then we're going to talk about 7 challenges the oceans are facing. I'm going to go into detail on one of those, which is sea level rise. And then I'm going to end with 7 things that we personally can do to ease our pressures on the ocean. So let's jump straight in. Well, the first reason why the ocean is so wonderful is it helps us breathe. And hardly any people realize this. And I didn't realize this, I don't think, until fairly recently. But the ocean has millions, well, billions and billions of tiny little plant-like organisms that we call plankton. So this is what they look like. You wouldn't see them. Well, I'm sure living in Singapore, you've all swum in the ocean. You won't have ever seen these. They're microscopic. You can only see them under a camera. But they're actually tiny little plants, and they grow and get their energy from photosynthesis. And in the process, they give off oxygen. And it's been estimated about 80% of the oxygen that we breathe, that I'm breathing at the moment, comes from the ocean. So that's the first reason why the ocean is so wonderful. It helps us to breathe. The second thing why the ocean is so incredible, and this is a very obvious one, but it's a really important source of food. It's been estimated, again, these are only estimates, they're our best guess, but it's estimated that about 3 billion people, almost half of the world's population, the sea is their #1 source of protein. Now, obviously, the majority of that comes from fish, but again, living in Singapore, I'm sure you'll eat a lot of lobster, prawns, crayfish, even seaweed. All of that comes from our amazing ocean. And I'm sure Singapore, more than probably anywhere else in the world, really relies on the sea for your food. The Earth, the ocean is our largest ecosystem. What do I mean by ecosystem? Well, I love the way the National Geographic Society defines it. An ecosystem is an area where plants, animals, other organisms as interact with the weather, the landscape, and work together to form a bubble. The word bubble is very appropriate at the moment with COVID. But the ocean is our largest ecosystem. It's been estimated about 94% of Earth's living species exist within the oceans. And we have 3 main wonderful ecosystems. We have coral reefs, where fish of all different sizes and coral interact together and support each other with birds and sharks and many other creatures. But we also have mangroves and salt marshes, and all together they provide an incredible service to humanity, not just from food and tourism, but they maintain the health of the marine environment. They suck up carbon. They do many, many wonderful things for us. The fourth thing why the oceans are so wonderful is it creates millions of jobs. It's been estimated recently that the livelihoods of something like 870 million people in the world depend on fisheries and aquaculture. Not only that, but 90% of the world's trade is by sea. So the aquaculture can be very small scale, like this wonderful fishing. I visited this site in Sri Lanka, to large scale kind of commercial feats. But I think it's probably even closer to 1 billion people's daily livelihoods depend directly on the sea. Now, we might think with increases in air travel that a lot of trade and things happens by the air, but it doesn't. 90% of the things move around the world via big container ships, and certainly a lot of the things that you're buying in the UK, a lot of the things you buy in Singapore will have come there from different parts of the world by the sea. Now, these are just 2 examples. Many others exist, tourism and things like that. So, a huge proportion of people on the planet rely on the ocean for their livelihoods. Next, the ocean regulates our climate. And again, I think this is really underappreciated. People think about the atmosphere, but the ocean is really key in controlling the kind of weather we have today. So the ocean sucks up heat, and it's one of the main mechanisms how heat gets from the equator, which receives the majority of the Earth's warming, to the poles. Now, I love this website here, which is earth.nullschool.net, and I'd encourage you all to go and have a look at it. But you can go on and see in real time kind of atmospheric variability, but also ocean variability. So the color here is ocean temperature, and you can see really nice warm water in and around the poles. But these white lines here are ocean currents, and this is probably the most famous current in the world, the Gulf Stream. Now, if you focus on the UK and Europe, we should have a similar climate to Canada, which is very cold because we're on the same latitude. But actually, our water around the UK is much warmer, and our climate is actually much warmer than it should be because of this warm water being transferred by the Gulf Stream. Now, this is just Europe, but in Singapore and elsewhere around the world, the ocean plays a really key role in determining your climate, influencing, for example, El Nino Southern Oscillation. The sixth reason why our oceans are so wonderful is it keeps us happy. Various studies have shown that blue spaces, so just going for walks by the ocean, just listening to the sounds of waves, improves our moods and reduces stress. And I know it does for me. I absolutely love walking near to the ocean. I'm very lucky to live right next to a kind of estuary here. But not only that, the ocean is a really important source of medicines. In recent years, a number of scientists have found that the luminescent properties in jellyfish and in corals, and in fact, we have an expert working in my department, can be used to diagnose certain cancers. And I think we're only just getting started. I think over the next sort of few decades, the oceans will reveal many more incredible medicines that we don't yet know about that will come from the ocean. And then finally, the ocean makes us happy. I love to swim in the ocean. When I swim in the ocean, or whenever I possibly can. In fact, one year when I lived in Australia, I swam in the ocean every single day. I love to snorkel, I love to surf. Many here in Southampton love to sail. And some of us even fall in love by the ocean. This is me there on the left, a terrible photo when I thought I looked good with long hair. And this is my wife, Fiona, on the right. And this is the day we actually met. We met on the Isle of Wight, next to the ocean on a beach, and fell in love there. So for me personally, the ocean's a very special place in that regard, and I'm sure many of you as well have met partners on the beach. Okay, so now I want to get into the word sustainability and what does it mean? And I think we all think we know what sustainability is, but when we try and define it, it's quite hard. Sustainability, I really like the Brundtland's Commission's report definition, but it says we must meet the needs of the present generation without compromising the ability of future generations to meet their own needs. So this is my daughter here on the left, quite young, a bit older on the right, more recently, and my wife in the background. Our ocean is such a wonderful thing. It provides us with so much food, but how do we make sure that we sustain that? How do we make sure that we can utilize the ocean for all of these things without compromising it? I want my daughter here to have a beautiful ocean when she's grown up. I want her children to have a beautiful ocean. How do we utilize the oceans for these wonderful things without damaging it? Now, I would love to say that the ocean is stress-free, but the truth is it's not. It's under immense pressures, and I'll just quickly go through some of these. You're all aware of this, and scientists, including myself, have been talking about this for decades. And it's really nice with David Attenborough and the Blue Planet that finally people are starting to take notice. But the oceans are increasingly becoming a plastic soup that's killing thousands of marine animals every day. That plastic breaks down, ends up as microplastics and gets eaten by fish. And even us, we've got plastics in our stomachs now from eating fish. Ocean Asia, a charity, predicts that this year alone, 1.5 billion face masks will enter the ocean. So I'm really worried that COVID is just going to make this situation a lot worse. Not only that, but the second pressure that our oceans are facing are overfishing. As technology technology has improved. We found ways to catch significantly more fish than we have in the past. The United Nations Food and Agricultural Organization estimated in 2018 that 33.1% of the world's fish stock are subject to overfishing. And overfishing, particularly of the long life, top of the food chains like sharks and tunas, can have dramatic effects on other smaller fish and irreversibly change the harmony of the marine life. We're also sadly pumping billions of cubic meters of untreated waste into the ocean. Now, countries like Singapore, the UK, we no longer do this, although we did do this in the past, but still around the world, it's estimated that something like 80% of the water that's entering the ocean is untreated. And one of the key issues that is causing is nutrient pollutions. So this is a picture of the Mississippi Delta in the Gulf of Mexico in the US, and we've now got fantastic fertilizers that mean we can have bumper huge crops, but when it rains, those fertilizers make their way into river and go into the oceans, and the nutrients in those fertilizers can simulate biological, chemical and physical processes known as eutrophication, and basically you get algal blooms here. So you can see these kind of green color here is huge algal blooms, and those take up a lot of the oxygen and can actually form dead zones, which can have really detrimental effects. And I've got a PhD studying this for one of our estuaries on the south coast. Another huge pressure is the destruction of marine habitats. So I've talked about coral reefs, I've talked about salt marshes and briefly about mangroves. But this is the Sundarbans in Bangladesh, one of the biggest mangrove forests in the world. And mangroves are fantastic, not just for protection for animals and food, but they provide a natural flood defense to very low-lying Bangladesh. They stop the waves propagating further up the estuary. Now, thankfully, the mangroves here haven't declined much, but it's been estimated that their health has reduced by about 25%. And there's lots of places around the world, including where I live, where things like mangroves and salt marshes are being destroyed very, very rapidly. Now, I really don't need to spend long on this, because all of you have seen on TV massive oil spills like this one, the Deepwater Horizon, which just pumped billions of gallons of oil and had massive detrimental effects to marine life. And sadly, I'm sure we'll see more of these over the years, although safety has on average got a little bit better. And finally, the seventh one is climate change, which is just having a profound impact on our oceans. So increasing the amount of carbon dioxide in the atmosphere changes the pH of the ocean. And this can dramatically alter marine ecosystems, which are very, very sensitive. And one of the biggest ones is corals. So corals are actually two creatures living together symbiotically. And when the water temperature gets too high, one of those creatures dies and the coral turns white. And to me, this is the most dramatic, one of the most dramatic things of climate change that really touches me, that, projections have suggested that in the next 20 to 30 years, we might lose almost all of our corals. And by 2100, there might not be any corals left, which I just think is a disaster. I love diving, I love snorkeling, and I want my daughter to experience that. So what I want to do now is take 10 minutes and just talk about climate change. And I often think climate change is relatively poorly understood sometimes. We hear about it all the time. So I just wanted to give you a very simple climate 101. I'm sure most of you know this, but let's just recap it anyway. So we've got our sun up here in the left-hand corner. And this obviously warms our planet. And most of that radiation is observed by the Earth's surface, and it warms during the day. Some of that energy is reflected by the atmosphere out into space. Now, during the night, the Earth is warmed up during the day. During the night, a lot of that energy is emitted as infrared radiation, and it hits the Earth's atmosphere. Some of that radiation is reflected into space, but some of that is reflected back to Earth. And it's that component, that small arrow here that's reflected back to Earth, that kind of keeps our planet nice and warm and livable. Now, we've been doing one of the biggest experiments that have ever been undertaken. We've been pumping millions and millions amounts of carbon dioxide into the atmosphere. We've been cutting down trees, we've been concreting large areas. It's dramatically increased the carbon dioxide in our atmosphere. So this is one of the most famous graphs in the world. This goes from 1960 on the left to 2020, and it shows the concentration of carbon dioxide in the atmosphere. And this was set up by Charles David Keeling, one of the world's famous scientists. He's died now, sadly, but he observed CO2 in Hawaii, measured it very accurately. And you can see that CO2 has dramatically increased from 320 parts per million up until 460 today. And what's that done? That's thickened essentially kind of thickened the atmosphere. So now less energy is radiated out into space and more is radiated back into the Earth. And that has warmed up our planet. Now, if we look at data from NOAA, the National Oceanographic and Atmospheric Administration in the UK, but also from lots of other organizations around the world, we consistently see that our planet has warmed. So this graph goes from 1880 to 2019, and there's a kind of average baseline here. But you can see over time, our planet has warmed up by about 1 degree. And really dramatically over the last sort of 10 years. Now, I absolutely love this image here, which is produced by one of my friends, Professor Ed Hawkins from Reading. And each line here is a year going from 1850 to today. And the blues are kind of colder temperatures, the reds are warmer temperatures. But what you can see is our planet has dramatically warmed up. We had a very warm year in sort of 1940s here. But you can see, so some years are warmer than others, some years are colder, but dramatically that has increased until we had a particularly warm year in 2016, and another one this year. And if you look at the 10 warmest years on record, it's very, very scary. Almost all of those have occurred in the last 10 years. The 10th one is in the last 20 years, but all of them have occurred recently, and we just keep on breaking the records. So 2020 is now tied with 2016, and we've seen a degree warming. Now that might not sound like much, but it is having profound effects on our planet. So this is the Oak Glacier in Iceland. And on the left is what the glacier looked like in 1986. And today that glacier has disappeared. Now the Icelandic government actually held the world's first funeral for this glacier. They went up to this glacier and they held a funeral, and they actually put this plaque. And I find this quite moving. It almost brings me to tears, actually. And I'll read it to you. It says, "A letter to the future. Oak is the first Icelandic glacier to lose its status as a glacier. In the next 200 years, all glaciers are expected to follow the same path. This monument is to acknowledge that we know what's happening and we know what needs to be done. Only you know if we did it." And I like it. It says down the bottom, August 2019, but even more profound than that, it says 415 parts per million of CO2. And I'm sure there'll be many more funerals for glaciers over the years. So climate change has a whole wide range of facts. And I love this figure here from the Job One for Humanity website. So climate change can change our rain and snowfall patterns. It can lead to stronger storms, more hurricanes. We're seeing that. It can affect animal migration. We're getting higher temperatures and more heat waves in cities. We're getting more droughts and wildfires. We saw that dramatically last year in Australia and California. I've already shown you that we're getting less snow and ice. It's changing the permafrost. But key for us is it's warming the oceans. It's leading to damage of corals. And more significantly than that, I think probably most certain consequences of climate change is rising sea levels. As the ocean warms, it expands, the water level goes up. As ice melts from glaciers in Greenland and Antarctica, it's increasing the volume of the ocean. And this is what I've spent the last 20 years looking at. Now, these are 3 long tide gauge records from around the world over the last 200 years, so 1800 to 2020. And I've just plotted each of these above each other for presentation purposes. But here we have 3 of the longest measurements of sea level. Now, every year sea level goes up and goes down, but over time you can see that sea levels are relatively stable from 1800 to 1850, but since around 1850 sea levels have dramatically increased, and that rate of rise is accelerating. Over the 20th century, that rate was about 1.7 meters. We have a truly global picture of sea level from satellites, and this is beautiful color plot here shows the satellite measurements. Almost all of the seas worldwide have risen. You can see that yellow color. The rate is currently 3 millimeters per year, which is twice the rate it was over the 20th century. So that rate of rise is getting faster and faster. And you can see in and around Indonesia, even as far as Singapore, that rate of rise is dramatically faster than the global mean. So there's regions of the oceans that are rising faster than others, but almost consistently across the planet, we're getting a 3 millimeter per year rise, and that rate is just increasing every year. Now, the Intergovernmental Panel on Climate Change projects this, and the most recent projections from the Special Report on the Ocean and Cryosphere say that by 2100, on the left is a low emission scenario, we could see about 50 centimeters of sea level rise. But if we continue to emit carbon as we're currently doing, we'll see at least a meter of sea level rise. And this is where the Paris Agreement is so important. So the Paris Agreement, countries from all around the world got together and signed this agreement. And thankfully, America have just come back into this after withdrawing. But they committed to holding the increase in global average temperature to well below 2 degrees, ideally to below 1.5 degrees, recognizing that this would significantly reduce the risks and impacts of climate change. Now, the motivation for this was small island developing states. So people like the Maldives were real key players in making this happen. But what's really interesting is if we can follow the Paris Agreement, then many of the impacts of climate change will be reduced. So, and I really hope we do. But sea level rise is different. Sea level rise is the one that's apart, in that sea levels take a very long time to respond. So even if we reduce our emissions, sea levels are going to continue to rise for hundreds, if not thousands of years. That's because we've only warmed the surface of the ocean, and that heat will slowly transfer down into the depths of the ocean. And also, once you start melting ice, if you stop temperature increase, it doesn't just stop melting straight away. There's a kind of time lag. And we did some modeling of this. And this is a plot of what sea level rise would look like with 1.5 degrees of warming in the grey. And you can see that even if we reduce our emissions and keep temperature to 1.5, sea levels will continue to rise all the way out to 2300 and beyond. That rate will be higher if we keep our temperature at 2 degrees, but if we carry on emitting as we are, we could see up to 5 meters of sea level rise by 2300. So with sea level, it's not so much what's going to happen by 2100, it's what's going to happen in 200, 300 years time, which is just almost impossible for governments, let alone scientists, to think about. But the Paris Agreement is so important because what we do today could influence our children's children, and we could save up to 4 meters of sea level rise. So we will experience 1 meters of sea level rise. It's just whether it happens this century or in the next 2. Now, just very quickly, I want to go over 3 areas in the world that are particularly sensitive to sea level rise. The first is small island developing states, and there's 58 small island developing states. And actually, Singapore is part of this, although I think your challenges are slightly different to many of the other ones. So, for example, the Maldives in the Indian Ocean, the Solomon Islands, Vanuatu in the Pacific, some Caribbean islands there. Now, when we think of a small island developing state like the Maldives, we tend to think of a paradise, a tourism paradise like this. These islands, although they're all incredibly different, they're all fairly remote, other than Singapore is an exception there. They all have quite high energy costs. They're heavily dependent on trade. They have a disproportionately expensive infrastructure administration, and often very, very fragile physical, biological, and chemical environments that are susceptible to natural disasters. Now, we tend to think of small islands like this, but this is what the capital of the Maldives looks like. It's one of the most densely populated places on Earth, barely a meter above sea level. And all of these climate change, so many different impacts, from changes in coral to reduction of mangroves to increases in rainfall and wind and hurricanes, but particularly sea level rise, are going to dramatically influence these islands. One of the islands that we've been focusing on research-wise is the Solomon Islands. And this is Wilandi Island, which was a sandbank off the coast of the Solomon Islands. And the population grew from about 300 years ago in the 60s to about 1,000 people in 2009. This is visited. But in 2009, this island was destroyed by a storm. And this was a photo taken 3 years ago from another angle. And only 2 houses remain. But my PhD student visited this island last year, and all of those houses are gone. So 1,000 people and their culture, they've had to move to the mainland, and they're facing huge challenges. The second area is deltas. And this is particularly a problem for Southeast Asia, where some of the world's biggest deltas are. So deltas are where you get a big river like the Amazon or the Mekong carrying lots of sediment, and it creates these vast, flat, incredibly fertile plains. And one of the ones we've been looking at is the Mekong Delta. So I've got a project on the Mekong at the moment. On the left is the population of the Mekong Delta. So the Mekong Delta houses about 18 million people, and almost half of the rice grown in Vietnam comes from this region. It's an incredibly fertile region, but many of the people living on the Delta are poor. And if you do get a major event, it can set back sort of economic by decades. On the right is the elevation, and you can see many of these 18 million people are living on these blue areas that are less than a meter above sea level rise. In 1997, Typhoon Linda killed 4,000 people on the Mekong Delta, destroyed 300,000 homes, and flooded a staggering 4,500 kilometers squared of rice paddy. It's one of the worst typhoons in history, and these typhoons are getting more regular. So it's really worrying, and there's many deltas around the world that are really sensitive to sea level rise, but also other human pressures. The final thing I just wanted to talk about is coastal cities, because I think this is where really sea level rise is going to be felt most strongly. It was estimated that there's about 150 coastal cities around the world with populations of at least 1 million. Jakarta is a very significant one, where already they're talking about possibly having to move the capital of Indonesia because of issues with subsidence and sea level rise. But obviously Singapore, not only a city, but a country there as well. But London is particularly vulnerable to sea level rise. And here in London, we're very lucky to have this £1 billion coastal defence infrastructure called the Thames Barrier that protects London. But without this, London would be in a very, very precautious place. And as sea levels rise, the number of closures is increasing dramatically. We've already closed the barrier 195 times, and it's unclear how sustainable this is going to be. So it's really quite worrying. So, and obviously Singapore is a key coastal city, key coastal country there as well, that obviously, you know, and I've worked with quite a few people from Singapore, particularly from NTU University, but others. And, you know, thankfully you have some very good defences in place, but as sea levels rise, we have to think very carefully about those. So our planet is warming, and it is worrying, but what can we do about it? Well, I think we need a top-down approach, and I think we need a bottom-up approach. So from top down, I think we need to be writing to our politicians, encouraging them to really take climate change seriously, and really hope that we can make some strides through in COP. But I think on another level, a bottom-up level, all of us need to take some responsibility for this and say, what can I do personally? And I want each of you now and after this talk to just sit down quietly somewhere and just think, what can I do about this? Now, my daughter and I and my wife, we sat down and thought, well, what are we doing over the last few years? And here I just want to talk about 7 things that we're doing. Some of these are quite UK focused, but let me go over them. So the first thing that I've done personally is I've cycled to work every day for the last 10 years. I haven't driven a car. I've cycled to work, and we've only kept one car, which we try not to use that much. The next thing that we've done as a family is we're trying to eat less meat. That's quite good. Actually eat more vegetables. I love meat. I'll never give up meat. But last year, as a bit of fun, we had a meat-free week, and we just ate vegetables, but we're trying to eat less meat. One of the key things we're doing as well is trying not to use single plastic. So this picture at the top here, my wife's gone out and bought a lot of shampoo bars, which don't come with plastic. We've got this bottle here that we go to the shops and fill up with soap and hand wash. We're using bamboo toothbrushes to try and get away from single-use plastics. Up the right hand, we're trying to buy new, we're trying to buy secondhand things. And my wife has actually gone down to our tip, and my daughter and I love going with her, but she's absolutely amazing at recycling furniture. So about a third to half of the furniture in our house now has got from the tip, which has really broken down, but my wife's incredibly talented, has come back, painted it, sanded it down. This cabinet here almost looks brand new now, but you wouldn't have known that. Now, this picture here, my wife is holding, my daughter's holding insulation. We try to insulate our homes. We don't have to have so much heating on. I'm guessing this isn't a problem in Singapore, but here, house insulation. We've replaced all of the light bulbs in our house with energy saving, and we've just gone over to an energy supply that's 100% renewable. Now, I think this will change this last year with COVID, but my daughter here is demonstrating video conferencing. So even in the last couple of years, I've tried not to go to as many conferences as I can. As an academic, I travel around the world, but tried to reduce that and attend more conferences via video conferencing. And hopefully COVID will improve that. So these are just 7 things that we've done. Some of them are a bit UK focused, but do a bit of research and work out what you can do. Now, I didn't want to end on a negative point. I wanted to end on a positive point. Who are these boys here? I'll just give you 1 minute. Can you put into the chat, do you recognize any of these faces? Who are they? I'm just going to pause for 30 seconds, but please enter in the chat. Do you know who these boys are? Thank you, Denise. You are right. These were the boys from Thailand, the Boers football team who were caught in a cave. Thank you, Darren. Yeah. Now, I think it's absolutely incredible. I did quite a bit of caving as a kid, as a teenager, growing up. I've got lots of friends. I've got friends that are cave divers. Now, I thought when I was glued to the TV, I spent hours each day watching this. I thought there was no possible way they could rescue those boys under those conditions. It just seemed undoable. And yet the world came together. We had divers from Thailand, divers from Australia, from the UK, all over the world came together. People sent masks from all over the world and pumps from everywhere, and people came together and rescued those boys. And I think if we can come together as all the nations of the world, I'm really confident that we can have a healthy, sustainable planet and tackle climate change. Okay, thank you very much for your time. It's been a real pleasure to talk to you. If you're interested to hear any more information about the sort of research we do or the courses we teach, then please do scan this barcode here. But yeah, thank you very much. It's been a real pleasure to join you, and I'll pass back to Lizzie.
Thank you, Dr. Haigh. That was very insightful and has certainly given us a lot to think about. We have about 15 minutes left, so we might be able to take some questions. A few people had submitted questions when they registered for the lecture, and then we also have a few which have come in through the chat. So I'll just put a few across to you. You did mention the mangrove swarms and how many conservationists have been talking about the importance of these mangroves in protecting our coastlines. There was a question that came through explaining that, reiterating that, saying that the mangrove swarms, they buffer the shores from powerful waves, reducing the likelihood of coastal flooding. Are there other actions that governments, organizations should be taking to be protecting these swarms? Is there something that you could comment on?
Yes, sure. So it's a really exciting area, but increasingly we're starting to look for what we call nature-based solutions. So we can't just keep raising flood defences. It's not possible. And here in the UK, where we have a long coastline, we just can't defend the coast everywhere. So we have to look for solutions that are more natural and sustainable. So mangroves and corals are a really fantastic natural prevention. Corals in particular stop about 80% of the waves reaching the coast, and mangroves even more so, things like salt marshes. So here in the UK, one of the things we're doing is actually what's called managed retreat, whereas in some areas, particularly in areas that are not very inhabited, we're actually moving back and we're creating areas that are free to flood. In Hamburg, they're doing some really innovative solutions where they've got car parks, which with enough warning, they can actually put the water and flood those car parks so that the rest of the city of mangroves and salt marshes, putting huge volumes of sediment on the beach like they've done in Holland. All of those are sort of more natural, sustainable ways. But yeah, if anyone's interested, please email me and I can send some resources your way of other nature-based solutions. But if you just Google nature-based solutions, you'll find lots of things that are already starting to take place. Thank you, Lizzie.
Thank you, Dr. Haigh. There was another question that came in, and you did allude to that just now. But could you talk about some other biotechnological approaches which have already been implemented to conserve the oceans, something that we could then look at, to be implementing in Singapore too?
Yeah, I'm not a particularly expert in this area, but we do have a couple of staff members here that really work in the area. So there's someone's suggested recently even sprinkling chemicals over the ocean that kind of can encourage certain animals to grow that take up carbon dioxide. There's various things like that that have been suggested. Off the top of my head, I can't remember any at the moment, but feel free to email me and I can put whoever asked that question in touch with experts here that have looked at that. But yeah, hundreds and hundreds of solutions have been suggested. I'm not aware of any that are really taking place yet, just because we don't know enough about them. And there's worries that they seem good, but they might have detrimental effects. But yeah, if you send me an email, I can certainly put you in the right contact with the right people who know a lot more about that than I do. But yeah, greening is a really interesting one. So I'm working quite a lot with the Thames estuary and looking at sort of whether we can increase salt marsh growth along the banks there. That's a really nice one that it not only looks nice, but it provides this kind of buffer zone. So yeah, but please feel free to contact me and I'll try and put you in the contact with the right people.
Thank you, Dr. Haigh. Waylon had put in a question. If algae are green and supposed to photosynthesize and produce oxygen, then how do we also account for the lack of oxygen related to algal blooms?
That's a really good question. And I have to admit, I know very, very little about this area. So algae in themselves aren't too much of a problem unless there's a huge bloom. So again, it's a kind of sustainability issue. But what's happening, for example, there's an estuary here in Christchurch, but recently there's been a reduction in river flow in that area. So you're not getting as much fresh water to the coast, but you're getting huge volumes of these nutrients. And the algae themselves aren't a problem, but when you get a big volume of nutrients without much fresh water, you can get these enormous algal blooms where just too many algae grow at once. So again, algae aren't a problem as long as their numbers aren't too big. But when their numbers go too big because of this significant sort of pumping of nutrients to the ocean, that's when you can get the dead zones occurring, as they just take up all of the oxygen. So it's kind of that delicate balance. They are good, but not when there's too many of them.
Thanks again, Dr. Haigh. We have a few students, quite a few students who've joined the lecture today. So maybe, Dr. Haigh, could you give us some information about what sort of facilities, courses are on offer at the National Oceanography Centre at the university?
Yeah, sure. So within the National Oceanography Centre, we have 4 programs. We have oceanography, we have marine biology, we have geophysics and geology. And again, you can take courses as well that kind of mix those up. But what's really exciting about the Oceanography Centre, it's quite unique in that half of the building is the university, half of the building is the government. So it's a really, really exciting place to work. We have big ships, you can see them in the picture here, that go out into the ocean. We have smaller coastal vessels, but we also have a world-leading technology lab that produces kind of remotely operated vehicles. So I studied here. I came into the building in 1998 and I just fell in love with the place. And I loved it because it's kind of cutting edge research occurring at the same time as education. But yeah, please do scan the code there, have a look at it. And I also love the kind of multidisciplinary aspects. So I'm working with engineers, I'm working with geographers, across the university, even in computer science, kind of new technology. So yeah, please do click on those websites there, scan this code. And Lizzie from Southampton is joining us. I'm sure can also answer any of your questions.
Lizzie, I know you're online. Do you want to unmute yourself? And is there anything that you could add to what Dr. Haigh just said?
Yeah, I think I was going to ask Dr. Haigh what a good background would be if you do want to study these courses. I've heard that if the course is oceanography is quite a mix of biology, chemistry, physics and maths. Is that correct?
Yeah, so the thing is, in the first year, the courses are all quite generic. We do a bit of physics, a bit of chemistry, a bit of biology, but then you sort of specialize. So I very much specialized in the physics route because I didn't particularly like chemistry or geology or biology at school. So my background was kind of physics, maths, and geography. But many of our students come from more kind of, they study biology, chemistry, and another subject. So really it's quite varied actually. And then, yeah, in the first year we cover a lot of those materials, but as you go into your second, third and fourth year, you can kind of specialize in what you like, whether you like the kind of chemistry or the biology more. But yeah, if you want to study marine biology, which is probably our most popular course, then it would be expected that you've covered quite a lot of sort of biology and chemical subjects.
And do you have any tips? I know some of these courses can be quite popular. Do you have any tips for how a student could boost their application?
Yeah, sure. I mean, so first of all, when I look through applications, I want to see a real keenness that, you know, this is their first choice. This is something that they've been passionate about for a long time. It's always nice to see things where people have volunteered to work in a kind of marine-based charity or organization or an aquarium, things like that, just doing some sort of extra activities. Or one of the things I quite like is we have a massive online course, the MOOC course, which I'm sure Lizzie can share more details with, but people who have gone online and done one of those courses beforehand, and we've had 9-year-old kids do those courses and really love them. So yeah, just a few things, and please feel free to add any I've missed, Lizzie.
Thank you very much. No, that's really good tips. I was thinking about the MOOC as well, and I'll put a link in a moment. If anybody does have any questions about studying at Southampton or how to apply, then do feel free to contact me. So I'm the representative for Southeast Asia, and that's my email address. I'm just putting into the chat for you.
Are there any other questions from participants? You could unmute yourself and put the question to Dr. Haigh. So there was a comment in there, Dr. Haigh, about us in Singapore with rising sea levels in the next 50 to 100 years. Should we all be thinking about moving to Western Europe or Africa as well? So I think those were very powerful images that you put about the island, which you know, had 2 houses left and then none more recently. So I think it's brought the message a little closer to home for us. Our tiny red dot, a little red dot here.
I guess it depends on the kind of rate and level of sea level rise. So I think Singapore, like the UK, is quite lucky in that we have the resources, we have the money to deal with this. Now, in Singapore, one of your biggest issues is lack of land. And I'm aware that you've actually purchased sand from other countries. Now, what I've been very impressed with Singapore is that when you have reclaimed land, you've actually raised it at quite a high height above sea level. So I would be fairly confident that Singapore could certainly cope with 1 meter, if not 2 meters of sea level rise. If it's beyond 2 meters, then I think you've got an issue. But also, I think you're lucky there in that you can justify the cost. So here in the UK, for example, one of the things they've been doing is kind of partnership funding. So if a town wants a flood defense, they actually, some of the businesses have to provide. So that's one thing you might have to look into Singapore, where actually hotels and businesses on the coast actually have to contribute to the cost of flood defense. It's not all covered by the government. But I would say in Singapore, you know, I would be fairly confident that you could handle at least 1 meter of sea level rise. But I think sea levels are going to continue to rise for hundreds of years. So, and also I'd love to see people challenging unique ways, floating houses, floating hotels, kind of blue-green cities and getting that right. But if anywhere could get it right, I think Singapore could.
One of our participants has just added to that comment. The name that comes up is General. Would you like to just expand on the comment that you made?
I haven't directly worked with the Singapore government for a few years, but as I was aware, they have this term called polder, which is in the UK we have a flood defence, but behind the flood defence the land's actually lower. But what I know you've done in Singapore is actually keep the land everywhere. But yes, certainly some of the new developments that I saw were at least 2 meters above sea level. So I'm assuming that's what that person is referring to. But if I've misinterpreted that, please just send me an email and I can help to clarify.
May I ask a question?
Sure.
Yes, of course. Yes.
Hi, I'm Vincent. My entire geography class is actually watching your lecture, and I know that there's a lot of individual things that we can do, like changing our lifestyle to be more environmentally friendly. But is there anything we can do as like a group, as like a class, to help support this, kind of thing? Is it just raising awareness, or can we like go out and actually, do something?
I mean, that's an absolutely fantastic question, and probably one I need to think about a bit more. But first of all, thank you so much for attending this talk. But I would say challenge each other and encourage each other. So within the classroom, maybe have competitions about who can use the least amount of plastic that week, or who can turn the lights off after they've left every room. Little things like that. So yeah, as a class, I would try and come up with challenges that can, are relevant to your particular setting, your particular region. But I think MPs, members of government, listen to children sometimes more than they do adults. So I would encourage you to record a video message from your school and send that to the government. Send that to send that to Alison here to show at COP, anything like that where you can increase awareness. And this is where I think Greta has done such a fantastic job of, there is this school strike. Now, normally I would recommend that children don't strike, but it's been incredible seeing, children from all over the world. And I think leaders are taking them so much more seriously than if we as adults did it. So yeah, that's just some suggestions, but please feel free to contact me and I'll have a think about that.
All right, thank you.
And just like Dr. Haigh said, and Alison has also put in the chat, we at the British Council, we'd be really, really glad to be supporting you. If you wanted to, do that video as Dr. Haigh suggested, and then we'd be able to put that through across to all of our channels and our chats as well, and help you with creating that awareness. That would be part of our cultural relations mission and part of our COP26 commitment as well.
Please do send me an email, because maybe we could get a school in the UK, and between your school and our school, we could do something and send it to the British Council. That would be fantastic.
I'm afraid that's all that we have time for today. As I said, Dr. Haigh has another appointment right after this one. So on behalf of the British Council and everyone here today, Dr. Haigh, I'd like to thank you for the stimulating and thought-provoking insights that you've shared with us today. I'm sure we'll all be leaving the session with ideas on how we can each play our own part in preserving our blue planet. I'd also like to thank Amira and the Singapore Association for the Deaf for supporting us today with the sign language interpretation during the session. Once again, thank you everyone for being part of this great lecture. And we really look forward to inviting you back to more of these. As I said, we're going to have one lecture every month for the rest of the year. Typically, they're going to be running on the last Thursday of the month, same time, 5 p.m. Singapore time. So our next session is going to be on the 25th of February. And Professor Ilan Kelman from University College London, he'll be joining us, and he'll continue on this theme of climate change and environmental sustainability. And hopefully in the not too distant future, we might be able to resume the in-person lectures as well, as we used to do until, the world went berserk. So thank you again, everyone. Thank you for joining us today. Have a good evening. And for people who've joined us from the UK, have a good day. Thank you. Bye-bye.